great.
Whoa.
Yay, look at that. That's some serious beige there, isn't it? Right, let's get this on here. Okay, this is my first time to Kansasfest, and I've come here. My name's Neil, by the way. That's me. Thank you. Thank you very much. I don't know whether to say this at the start or at the end, but I was a bit nervous about coming and addressing today, but I've met a lot of you during the week, and I really want to thank you for making me feel very welcome. I've come all the way from Scotland at the suggestion of my good friend Rob McMillan, and I am so glad to be here. I'm having a blast. Not had a blast, I'm still having a blast. I'm really enjoying it. I'm going to drop the microphone in a second because one thing that intimidated me the first day I came for a session was, of course, the keynote speech by Roger. He set the bar pretty high. In fact, it's been pretty high all week, and I thought, God, my presentation going to be any good? But I thought, I know what I can do. Roger was making a big play of going behind the screen, and I thought, I know what I'll do. I will do my great reveal from in front of the screen. Not on Facebook. Some of you may have seen this logo before, like maybe yesterday, perhaps. Yeah. Right. Now I've got to go and flip this back on. Thank you for your encouragement. Right, here we go. Is that a good place for it? Does that sound okay? Yep. Yeah, you got me clear there? Okay.
Just speaking out the right side of your mouth.
Yeah. Okay. Well, I ran this through with a friend of mine who wasn't pure literate, and it ran to about 35 minutes. So I'm going to skim through some of the more lighter parts, but they're easy to go through. So anyway, I'm here to talk today about BBC Microcomputer, which was a very important computer in the UK, and as I describe it, a computer that inspired a UK generation. In 1980-81, the British Broadcasting Corporation, which I shall now refer to as the BBC, they had long had a remit to do educational output for the British people. So they identified a need with all the now arriving personal computers that they thought, well, we should have a BBC microcomputer, and they launched what was called the BBC Computer Literacy Project. Let me just check a bit here. I'm just going to check something. There we go. Yeah. This was to comprise of 3 parts. They would have a television series, and there would be a BBC computer. They didn't know at the time it was going to look like this. And there would be they were doing this project in conjunction with the National Extension College, the NEC, not the NEC for computers. And they were going to create a book called 30-Hour Basic that would teach people how to program in BASIC. However, also the BBC User Guide, which I have a copy of here, would also form part of that project to make it understandable to learn BASIC. So they put an invite to all the British computer companies to submit tender to get the contract to make the BBC computer. A long story, and a really long story short, that was won by a company called Acorn Computers. So, there we go. Right, next slide. So Acorn Computers. So Acorn were they were based in University City of Cambridge in the UK, and they already had a 6502 based computer out already on the market, and that was the Acorn Atom. And like a lot of early micros in the UK, and maybe probably in the States as well, these are available as a kit, but also pre-built because they were quite expensive. But Acorn's next computer was still at the prototype stage, and this was called the Acorn Proton, or was going to be the Acorn Proton. But they won the contract, and by winning the contract, that became the BBC Microcomputer. But there was other contenders that fell by the wayside in that competition. One was the New Brain, who were a strong contender at the start, and the Sinclair ZX Spectrum, which I've subsequently learned was the Timex Sinclair was in the UK. And that was actually launched about 4 months after the BBC Micro, because I think it was ready for market, but it wasn't actually launched yet. But it was maybe probably the prototype stage. Now, in 2009, the BBC broadcast a light-hearted TV drama called Micromem, which, if you haven't seen it, I encourage you to watch it. It's really good. It has a lot of accurate event information in there, but it's also been somewhat tweaked to make it a more entertainment. But this is how it covers the rivalry between Acorn and Sinclair for that, and you'll quite enjoy it. I think you really will. So I encourage you to watch that. Anyway, let's look at the prices of computers around about that time in the UK. So I've just picked 6 examples including the BBC Micro itself, and you can see our venerable Apple II Plus there coming in at £650. And that's for the 48K version. The red numbers are what that would be in translated pounds today, which is amazing. The BBC Micro came in at 400, which I thought was pretty expensive at the time. Actually, my parents thought it was pretty expensive at the time. I thought it was absurd to buy a Commodore's VIC-20 with 5K for that price. I mean, it really was. But Commodore, as you all know, was ready to up their game a bit. But this is 1982, and this is what was available. My 2 school friends at the time, they had Atari 800s before me. And there's the Atari, yo Atari! And it was quite expensive, $590. And there's the Sinclair ZX Spectrum, which was released about June 1982, and it had 48K for 175, which is pretty good actually, but it has a sponge for a keyboard. If you've ever seen one, and I've put this for reference here. If businesses would like to have been already buying Apple IIs and maybe pets, and I've put the Sharp to get the Japanese a look in with their MZ80As with their built-in cassettes. They were quite nice. I even considered one of those. I honestly thought the brochure was truthful. So let's look at a little bit of the specification of the BBC Micro. Now, there was 2 models, the Model A and the Model B, and I'm really going to talk about the Model B, to be honest, because the Model A had most of the I/O not there, stripped out, and only 16K of RAM. And the reason for that was because they were hoping to make them bulk sales to schools, so they could pick what they really wanted in them. And the one thing they probably would want would be networking. So that would take care of a lot of the difficulties. So this is the Model B primarily then. So we've got 6502 A at 2 megahertz, which was quite fast at the time, I think, or just getting that way. 32K of RAM, 16K operating system, and 16K basic. These were 2 separate pieces of silicon. In fact, you could actually pull the basic out and chuck it away if you wanted. Graphics resolution, maximum resolution was 640 by 256. Not really that clear on a domestic television, but because they were designed to be used on a domestic television. But the other resolutions were fine. And you had the usual 2, 4, and 16 colour modes. The palette was an 8-colour palette. I say 8 colours. I'll explain more about the palette later on. And it had hardware scrolling. Sound, 4 channels, 3 voice, 1 noise. Pretty versatile. 8-bit printer port, and an RS423, not 232 serial port. And the reason for, well, not the reason for it, but one of the benefits of that, it did have a longer run length. You could actually run longer cables on a 423. So if you wanted to run a cable from your school to your house, that was possible. Two analog joystick ports and buttons. I mentioned there also the 8-bit bidirectional user port. The analog ports and the user port, that was a gift to the hobbyist market. Electronics enthusiasts were all over this, like a rash. It really was. And the 1 megahertz bus expansion and tube second processor. Now, my good friend there was going to mention, I'll mention it a wee bit more later on, but these the tube is for second processors, and that's what he was about to allude to yesterday before I had to cut it off. And the 1 megahertz bus expansion was for pretty much anything that wasn't going to be going in the user port. You had three different outputs for your monitors, quite versatile, and the cassette system. You could have different speeds there. The floppy disk interface was optional even then on the BBC Micro Model B. Networking was not standard. Again, you'd want that if you had a school. And yeah, it had a keyboard, which was.
Do you have to make any adjustments to it if you were to run it in the US?
Yeah, this machine didn't make much of an impact in the US, and I think the reason for that is because, as you just understand, of course, we've got resolution of 256 scan lines, and that had to be capped to 200. So the library of software that was available in the UK, you weren't going to get that, because nobody was going to want to have bits missing, and you basically had to kind of hot start your own software industry for 200 scan lines. Not only that, the price was quite expensive because they had to put in the RF shielding that the FCC required, which we just couldn't. We didn't need that because our TV's noisy anyway. So yeah, you're right. That was a problem for the UK, and so it made no real impact in the US. I don't think so. Let's go on to the next one. In the box, large computer, power cable integrated plug, a UHF cable. As I said, they were designed to be expected to be connected to the domestic television, and you got a user guide, which I've just shown you here. It's an inch thick. That is some serious piece of work, that I'll tell you. And you got a welcome pack, which has 16 programs on it, or 15 programs, and in cassette form. Again, households in Britain were expected to have cassette players. We did eventually get floppies, but because the price came down, but most households were using their Spectrums and their BBCs and their televisions. It was just like, here's the computer, use what you've got. Go down to the store, buy cassettes. That's quite a good welcome pack. A lot of good software on that, actually. It really demonstrated what it could do. So I'll go through these next slides rather quick, because this is the physical appearance of the machine primarily, and I don't want to spend too much time on that, because I've got quite a few nice little technical bits to talk about. Large square machine, speaker over there, function key strip, plastic strip you lift up, put some paper underneath, put it down. Programs would use that. There's a blanking plate for a speech ROM socket over there. More about that later on. Let's have a quick look at the sockets in the back. So there's your 3 video inputs, the first 3 in there. And then we've got the RS432 serial port. Now this had a DIN plug in what's called a domino combination, a configuration, like 5 in a dice, for a die. Yeah? You ever seen that? Anybody ever seen that before? Right? The peculiarity of a 5-pin domino DIN plug is that you can turn it through 180 degrees, the connector, and put it back in. So there's 2 ways you can put it in. So can anyone hazard a guess as to why you would have a 180 degree change in plugging this in on a serial port?
Across the transmit and receive lines.
Yes! You could do null modem.
Clever.
It would have been if that's the way they barred it up. But they didn't. And for the life of me, I thought to myself, even I saw that, and I didn't go to college in Cambridge. So that's a rather disappointment. Analog joysticks, DB15, blank port for the Ethernet port if you had it, and yeah, we need this power switch. So what we've got next. All right, this is the underside of the big slab. All the connectors under there are like IDC connectors with clips on them, really strong stuff, nothing's going to fall out. There's a little bit of a ridge, kind of a gap here at either end for sliding gripping cables under so you can connect to them. The power supply would power your floppy drive, which is just a standard sugar style floppy drive with a track 0 sensor. That's harsh. So that, yeah, all these ports here, you can see the user port right in the middle there. That was another one. Let's get that case off. Right, here's the case off. You can see the blank area for the from socket there. There's a speaker, ribbon cable for the keyboard, the power supply, visited various spade connectors across the board to deliver the power. So there's no Molexes here, nothing sophisticated like that. No. We just sold our wires on there, man. That chap. This is the bit you're probably going to enjoy a lot, getting into a bit more techie stuff. So there's the circuit board by itself, and then I'm going to introduce the major players in our BBC drama. First and foremost, our good friend, the 650, right in the middle there, in charge of everything. There we go. That particular one looks like it's got a Rockwell logo on it. It's not a Mostec one. Licensing. Then down here we have 5 ROM sockets. Now, as I said earlier on, the operating system, we need that. So the 4 remaining ones, you literally don't need them if you don't want them. You can pull them out. Therefore, when you use the term banked ROMs, we use the term paged ROMs, but that's what they are. There's 3. Well, this one seems to be quite well populated. Oh, there's the RAM. These are quite well populated. You'd have a disk filing system. You can put other ones in there. I'll talk more about that later on. There's the RAM, as I said. What have we got next? Oh yeah, this is the optional Intel 8271 floppy disk controller and the floppy disk discrete chips there for operating that. Again, that was an option. Later, BBC's had Western Digital 1770, which is, I think, was even pin compatible. I'm not sure of that. We were talking crap. Certainly, my ST had one of those anyway. What next we got? Now, these 2 boys, the 6522 VIA, a pair of them, 2 of them. One was for the system for controlling. They've got 2 8-bit I/O ports and a few other, and timers as well. They're versatile, interface adapters, of course. And they have timers and ports. And the system one was for controlling system things, like each line would have a purpose, like scan lines or outputs or starting motors and things. And the other VIA was for the user. That was the printer port and the user port. The printer port was buffered, so it became by nature output only from the machine. But the user port was bidirectional. You could connect anything you like and decide which pins would be in, which would be out, which is very good. Then we have the 6845 cathode ray tube controller and the video ULA. This one, just to the right of the 6502, I'm not circled that one. That was an SA5050 teletext chip. BBC had teletext. I don't know if any of you know what teletext is, but I'll be talking about that later on. But that was the video system. These 2 chips here. That was the video ULA was obviously a custom chip. Right, quick rundown of what we could get for our machines. Yay, the floppy drives arrived. They were cheaper. We got into them big time. I never saw physically in the same room as me a hard disk, but they were available at the whopping 30 megabytes. The second processors, 6502, Z80, and I think for a 3216 Gluon. That was a 16-bit. Have you ever heard of that? No, it's mentioned in this manual as well. It's a 16-bit chip with a 32-bit internal architecture. I forget who makes it. National Semiconductor, that's it. Over there, all the expansions that didn't need matched ports or screens and things, they just looked like half a BBC with no keyboard. The teletext adapter over there, which I'll be talking about later on. Joysticks, mice, controllers, yep, we had loads of those. That big one right at the front was a bit stick, and it's like a 3-axis joystick. So you've got, it's a ball kind of joystick, the ball rolling about with calibration lines on it. And that's X and Y. But the top is a knob you could rotate in a 3rd dimension. CAD packages would use that. You could really measure, go depth and things like that. We had an AMX mouse there. That came in really rather late. It was emulating the Macintosh style. You had a program that would allow you to see file view, menu options and all that, and use that mouse going into the user port, I think. And what a self-respecting computer didn't have a logo? Well, we had mice for a logo like that, or turtles with a logo. Nice things. You could get EEPROM programmers to plug into the 1 megahertz bus, and various other things for the 1 megahertz. Let's look at now the screen resolution. Again, the BBC Model B at 32K, so we have them all. But the ones from 4 down was always available 10K and less. It was for the REAP1 Model A. The resolutions, as you can imagine, exchanging colours for resolution. And there's 2 strange text-only modes, which had less lines, 25 lines, and they looked very similar to, the 3 looked very similar to 1, but it had 25 lines, as I say, and it was just text. And this special teletext mode, yeah, when I talk about that later on, you'll enjoy some of that. Now, if there's anything that I could have changed, maybe a few things I would have changed with BBC Micro, but this was it. Although it said that a palette of 16 colours, yeah, it was really 8. And the extra 8 were just flashing colours. So I thought that was pretty poor. I mean, my Atari friends were drawing, they had brown and orange, and sky blue. And I thought, yeah, well, we've got something like that, but not quite the same. So if I had to choose anything, I would have changed that. That would have been the first thing I would have changed.
Maybe combined.
Combined. I think there was one game I noticed that shrunk the resolution so that the TV blended the colours together in a sort of punctilionism. So you could, it really was like art, but Labyrinth was the name of the game. But yeah, you couldn't do anything with other, every pixel was just one of these colours, really. It's pretty sad, I thought, but now, this is an important thing here. It's hard to, well, you must get this. The operating system, as I said, was separate from BASIC. And when you printed characters using commands like move, draw, plot, yeah, what you were actually doing was just issuing VDU commands or text control commands. Sorry.
You've got 5.
5 minutes. Oh man, I'm so far behind. All right.
Sorry.
All right. Well, you can get these. VDU commands were for a graphics terminal, and that's what they were. They were just like, you were basically talking to a graphics terminal, so you could record these commands and play them back later to get graphics quite fast. User-defined characters. You could redefine the characters. When you redefine the characters, they're not available in mode 7 because it was using that teletext chip. So when you redefine a character and then printed the screen and redefined it again, it did not affect characters that were on the screen already because it was fully bitmapped, every character. I want to power through here. Mode 7 teletext. I think this is one of the reasons why the BBC, maybe Acorn got the contract, because they were willing to put this chip in the machine. In the UK, British Television had text information broadcast with all the television pictures in the vertical blank. They transmitted data. And it looked kind of like this, down here. And only on the BBC Micro, this mode only used 1K of memory, but you could use graphics commands or codes to make colours change and draw the graphics. An Acorn teletext adapter would allow you to grab those broadcasted pages and process them. So if you wanted to get the racing scores or the news, you could process them like that. And it was good for designing. The BBC CFAX system, they even broadcast programs you could download. The BBC CFAX system ran from 1974 to 2012. Sound, quickly sound, yep, you had sound. The sound command was simple, but the envelope command made it complicated. You could do tons of things with sound. The speech system I mentioned earlier on was available. And the BBC newscaster at the time was Kenneth Kendall, and his voice was used for the wrong.
This is the BBC.
Yes. It seems like strange to talk about function key, but the truth is you could define your own command using the star key command. All star commands are actually the operating system command. That's nothing to do with BASIC. If you do star something, it goes to the operating system chip, and it does the thing. And we programmers would program all manner of great, easy, quick shortcuts in these things. And you know how you all know that your basics are tokenized. You could actually use the token. If you could print the character on the screen for the token and copy the character from the screen into your definition, you can cram tons of program into your 256 bytes of character definitions. I had a 1-key binary to decimal and hex button. So I could just, what's the hex for that? I just press this and go 101111, there you go. From programming, it was really good. Software, we had loads. Educational software primarily because what this was about. We had spreadsheets, the games, some were ported to other platforms, most notably Elite.
Yeah.
Yeah, that,
Perfect
yeah.
with that joystick.
Oh, yeah, man. You know it. But let's look at, now this is something more technical. If you started mucking around with the video hardware, you can start doing some video tricks to get some things. Here's an example where, I'll show you an example. This is Elite here. I'll get my mouse over there. Can I do this? Yeah, there's Elite. Elite reduced the width of the screen so it was 256 bytes per line. And then that would make the computations easier, as you know. It would change the resolution of the screen down here. Now you could get a vertical blank interrupt, but you couldn't get a scan line interrupt. You had to use one of those VIAs to set a timer to wake you up to get your changing. So, okay, better than counting cycles, but not as good as display listening to us from Rob there. And the elite did a stupid thing. They read the operating system ROM's definition of the characters. So it worked until the new release of the ROM, and then the characters looked like garbage. So now we'll do another release of that. Back to here, we've got a similar idea with the elite, with Revs. Revs stored the program on the screen and changed the colour of the palette to blue so you couldn't see it. Yeah, how about that? Save memory. How tight can you be? And this green here is the blue down here, and this resolution is your 320, and this is your 160. So that's pretty class, isn't it? That's a pretty good one, that. Oh, right, back here, get over here. BBC Basic, the important part of BBC Basic, standard basic, understands all the commands, has all the commands for doing colours and sound and that, but also it had structured basic. It was procedural. You didn't need to use GoSub and GoTo. You defined the procedures and functions with parameters. It had local variables. Computer scientists loved this. Straight out of Cambridge, that's what you'd expect. And this is why I bought it. Am I really done now? I'll wrap it up. Okay, wrap it up. Let's get straight onto this one here. Inbuilt 6502 assembler in the basic. If there's a peculiarity of this, is that you can't use dollar for hex, because that means a string in basic. So in this scenario, what you do is you have to use an ampersand. But this is a small demo here, doing a little program to add a few registers. I can show you all this offline. I want to just skip to the. I'll just skip here. Page ROMs. Page ROMs. There we are. One game in a socket. Rob wanted to see this. This is how the screen RAM was arranged for the screen memory. The first 8 bytes were the first bytes of the character. So you have to go. And then.
What nonsense is this?
Yeah, exactly.
It's rubbish.
Well, that's what I thought. That's what I thought. But we had magazines. Please, sir, can I have some more RAM? They were all over schools, and some are still in use today. There was tons of them. They were massive. Rooms big as this, full of BBC Micros in every school, college, right throughout the land. What happened next? They made new versions, BBC Master, Master Compact. The Acorn Electron was their own branded one from Acorn. It was slightly not as good. And finally, we'll get to near the last slide now. I'm actually just about finished now. What did Acorn do next? In 1987, Acorn came out with the Archimedes, and this was a major shift because they created a 32-bit RISC processor, and it was called the Acorn RISC machine, which you might know as the ARM chip. And because BBC Micros were all over schools, and the schools was a big market, and if you get them early, yeah, a chap called William Gates came across to the UK and went to see Acorn because he thought, I know where that's going. And then he said, will you run my MS-DOS on your Archimedes? And Acorn said, technically true. We don't need to run DOS. We've got RISC-OS, and that makes DOS look like crap. And that's technically true. I mean, RISC-OS is class. I mean, it's like a British version of the next step, right? I mean, really, it was brilliant, right? And who knows, if they had decided to run DOS, then logically next would have come Windows, and the whole thing could have been changed. A chap called Eben Upton, in his school days, was so inspired by the BBC Micro, and he lamented that today people were not doing I/O and programming robots and doing electronics with their computers anymore. They were sterile. And he decided to create a thing called the Raspberry Pi Foundation. And there's the Raspberry Pi there. And the Raspberry Pi, when it first came out, was available in 2 versions. Model A and Model B. Can I just I'll just close with my last set. I have a question. I'll have to answer any of your questions, but I have a question for you. Can anybody answer me that question? Don't look at your phones. Don't look at the internet. Does anyone have an answer to that one question? I was thinking, will they get it or will they not? Have a guess, anyway. See if a guess.
the cassette encoding, Kansas City standard.
God, that lady has it. Well done. Established in 1976, the Kansas City Protocol for cassettes, because it was a more robust. Cassettes were known to have problems, and the cassette system on BBC, you could rewind it and play it again if it had an error. So it was robust, and it was established here in Kansas City in 1976. Well done, you. Well done, well done. So, my last slide. Thank you. Thank you very much. Thank you.